Hello everyone and welcome to my new video. What is this video about? Well, I'm here in Max and what I would like to do today is explore visual audio. What's that? What's visual audio? Well, it's sort of like audio visual, but the other way around. You know, people talk a lot about audio visual. Oh, I want my visuals to like react to like the audio and you know, and they don't talk like that when they say that. That's just in my imagination. But yeah, people like audio reactive visuals, don't they? Oh, I do a thing and then the visuals go wah, and then a thing in the sound goes wah, and the visuals go wah. I'm actually going to go the other way around and look at ways at which we can generate audio from visual content in Max using some stuff. Using a combination of Jitter objects and MSP objects and JIT MSP objects. They exist. Lots of interesting stuff to explore. So to start with, what I'm going to do is I'm going to pull in those scratchy film textures, videos that I, with the patch unlocked, of course. I'm going to drag those in. And you might remember these from the video I did a couple of weeks ago or whatever. These are just some scratchy film textures that I got off this website called Vecteezy. I'm going to make a jit.gl.video plane here at transform reset 2. Connect the output of this jit.playlist. Is that what it's called? Jit.playlist. And then now if I play these, they should appear on my video plane. There we go. I don't need to see that message. Thanks. So these are just some scratchy film textures, which I used in a previous video, which I like very much. I'd like to get more of them. I think they're pretty cool. But we can actually use this to generate sound, right? And everything that's going to happen in the sound is a reflection of what's going on in the video. Because what we can do is actually take the content of this stuff and put it into a matrix. We're going to put it into a jit.matrix. We're going to give that matrix a name. Let's zoom in a bit. We're going to give that matrix a name. I'm going to call it V-Noise. And I'm going to say I want 4 planes for the alpha, the red, the blue, and the green, I think. So when you do jitter matrices, the alpha is first. And I need to make sure that it's at the dimensions of the video. So I'm going to make a jit.fps GUI, connect the output of that and ping this down and go to dim. Right. So apparently these videos are 1920 by 1080. Is that both of them? Let's have a look at both of them. All right. Okay. So I'm going to say that I want my matrix to be 1920 by 1080. Good. So I'm going to put that in. Whoa. I'm going to put that in there. And I might as well just plug this back into my video plane. Now, I've got a copy of this. Jit.playlist can spit out textures and matrices. I'm going to use the matrix because I'm going to do this all with JIT matrices. So that's now, I've got a copy of that there. And then that's going to, are you going to play? Right, so that's playing in my video plane. Right, so how do I convert that to audio? Well, we can use an object called jit.peak. And what jit.peak does is, let's have a look at the help file. Whoa! Jit.peak reads the value of one plane of a matrix cell at the position specified by signal inputs. This value is output as a signal. The object arguments are matrix name, dim, encapsulate, everything. Okay, so we can actually listen to this in the help file. So it sounds awful, but basically what we've got here is we've got a phaser reading from 0 to 1 multiplied by the x, by the number of dimensions on the x-axis. So this matrix here is specified that this is a 4-plane matrix with char type data, and the dimensions are 320 by 240. So on this first input, we're multiplying the phaser by the amount of dimensions there are on the x-axis, and then on the y-axis, I believe what we can do is we can kind of effectively move. If you imagine that there's a phaser going from left to right like this, can you see my mouse? It's probably very small. Let's do it on this big one here. So imagine that there's a phaser going from left to right really, really fast, the audio rate on the x-axis. We can then take a sort of static signal to move that to somewhere on the y-axis. So we could maybe like move to like this position or this position or something. I think that's what it's doing. If I'm wrong, please tell me in the comments. Anyway, let's try that. So what's this stuff here? So they've given it a name. That's the name of the matrix. And then 2 by 2 dim, count, and plane. Okay. All right. So I'm just going to copy that into my one. I'm just going to say, so I want it to be the same name as the matrix I'm reading into. Let's say dim input count. Let's say 2. So is that reading plane 2? or 2 inputs. What if I put 3 inputs? Sorry, yeah, okay, so that would be 3 inputs to read from. 1 for dim 0, dim 1, and dim 2. Okay, I don't want that. Let's just do 2 by 2 like I did in the help file. Right, okay, so now we can take a phaser. I'm going to set the phaser to 50 hertz. And I'm going to multiply that phaser. If we look at this through a live.scope rather, we can see that that's just a ramp. Well, it's going very, very, very fast. If I do it at 1, then that is ramping from 0 to 1 at 1 hertz, but that's too slow to make audio. So let's say 50 hertz. And we need to multiply that by the amount of dim dimensions there are, or rather cells there are in our X dimension, which is 1920. So let's multiply that by 1920. Let's say it's a float as well. Okay, let's connect that to that, and then connect that to that, and then let's make a live gain and connect the output of that to our live gain. And I can see that it's kind of doing some sound. So let's turn that down. Let's connect the output of our live gain to our speaker. Turn that up. Yes. Yes. So it sounds awful because it's just basically noise, but it's what's happening in the video. Look at the video and listen to the sound. Tasty, tasty AF. So we could, let's zoom out a little bit. We could jump to Jitter playlist is really good because you can just sort of jump to specific points here and loop it like that. So I'm looping this bit now. Or this bit here. We can play a different video. Let's play this one. There's a good bit of stuff there. Is it? Are you playing? Oh, I didn't have a loop on. There we go. That was good. Yes, fun. And now that this is all MSP audio, we can just do like a MSP processing with it. So if we wanted to maybe filter that, we could create like a state variable filter and make a live dial here and set that prototype to frequency, connect that to the frequency input, and then we've got like a little low pass filter on that. Very, very nice. We can load in a different video. Let's load in the chickens. The chickens is going to be interesting because... Why is the chickens going to be interesting? Well, because there's only a certain amount of stuff happening in a certain area of the frame. So currently, I believe on the y-axis, we're probably reading at 0. So we're basically reading across this top, like a row here on this second input. So if I was to create a signal here and say 0, I'm fairly certain that it's just going to read from left to right on the x-axis. Why isn't it looping? Got to turn looping on. There we go. At row 0 on the y-axis. So the y-axis is here. So that's all this stuff. So we're probably just going to get a static sound because there's nothing happening in that area of the frame. But if I change that to something like halfway down the frame, like what's half of 1080? 540. So if we set this to 540, we're now reading, I think, on the y-axis down here. So we'll get more changes in sound. No, we won't. Okay, why not? Why didn't that work? That worked in the rehearsal. I would think. Oh dear. Oh, maybe let's try 1. No, that shouldn't make any difference. Let's try that again. 540. Whoa, not 5040. 500. Interesting. All right, let's look at the help file again. What have they done here? Plane 2. That's what I've done. Let's just delete it and read. Oh my God, what have I done? Let's close that. Let's just delete that and try again. All right. All right. Interesting. Not happening. Let's try 1 and 2. Nope. Let's try 2 and 1. Okay, apologies everyone, slight edit there. I worked out what the problem was. Well, I made a change and that fixed it, and basically what I forgot to do was tell the matrix, which is reading all of this stuff or storing all of this stuff, to be float 32 type data. Once I put that in there, then that all works. So where was I? Yes, so now what I've done is I've set the Y position to be halfway down the frame, i.e. 540, which is half of 1080. So now on the x-axis, we're reading this way, but we're reading here on the y-axis about halfway through. So we'll hear some differences in the sound as the chickens move past that part of the frame. Right, so now we're hearing no change. And then as they move past, there we go. We're hearing some changes in the frame because essentially the jit.peak is reading one row of data and interpreting it as like a kind of wavetable, like a buffer, like a table of data, ones and zeros, or everything in between. And so we get these sounds. Okay. Glad I got that sorted. But we don't need to use video. We can use anything as long as it's a jitter matrix. So we could, in fact, use a camera. So let's make, I'll just make some space over here. Let's make a jit.grab, and I'm going to open the help file. I'm going to copy all of this stuff. Copy that, delete that, paste that here. Move that matrix over there. Let's move all of this over here. Okay. Let's make a toggle to turn the camera on. Let's say get dev lists, get format list, okay. And then I'm going to choose my Brio webcam, turn it on. And there I am. Hi, everyone. Welcome to my face. So I'm going to connect that now. Maybe I could make a switch here. Switch to. Yes. Will this work? Whoopsie. Let's see if this works. So let's put the movie files on there and the camera on there and make a toggle and just say +1. And then we can switch between. No, that didn't work. Okay, never mind. Let's just plug that straight in. Oh, no, wait a minute. Sorry. No, that will work. My mistake. Let's plug that into the video plane. And then now we've got a switch. Yes. We can switch between the chickens and me. Perhaps we're both chickens. Right, so now let's do the same thing with my camera. So again, if we set the y-axis to 0, now it's reading along the top here, which is just basically a load of white. But if I put my hand up here, finger-controlled pulse width modulation. Semaphore art rave. Okay, let's set this to 540 back in the middle. All right. Leave that at 540. Filter that down. Gesture controlled wub wub. No one does wub wub anymore. I'm such an old fart. Right, let's see if we can control that frequency of the phaser with a keyboard. Let's make a K slider. Oh my goodness me. Let's make a K slider, oh my goodness me. K slider. Let's go into the inspector. Let's set the low value to 1 and the high value to 127, I think. Okay, now we've got a nice big keyboard. Zoom out a little bit. Let's close the inspector. And then let's make a M to F to convert MIDI to frequency. Plug that into our phaser. And then we can control our video synth with a keyboard, and you can get your MIDI in here and choose what MIDI input device you want. I'm not going to do that now. We'll just use this K slider. Turn it up a little bit. It's interpretive dance meets multimedia. Okay. So that's one way that you can do it with the camera. And then, of course, at any point we can switch back to the chickens or the scratchy film. But it doesn't end there, because we can also synthesize our own kind of waveforms from scratch using 3D stuff. So this is probably going to get a little bit more complicated. Can I make that a little smaller? Okay, this is going to be quite a big patch. Let's keep all this over here. All right, so let's start with, we're going to need to switch to, how am I going to get, okay, I think what I'll just do is I'll make an enable attribute for the video playing here, so I can just sort of turn it off. Okay, yeah, it's gone. So let's make a gl.grid shape at shape plane. Okay, there is our plane. And let's make a jit.bfg. 3 planes, float 32 type data. Let's say 100 by, let's try 100 by 1. Let's try 100 by 1 by 1. Let's see what that looks like. Let's take a render. Oh my goodness me. Let's zoom out a bit. Let's take a render bang from our jit.world, plug that in there. We didn't specify a noise, but a basis. Let's say at basis, noise.distorted is the one I like to use. No, that did not work. Did I spell that right? Jit.bfg, 32, 1 by 1, but why isn't that working? Okay, noise.distort. Yeah, my basis is right. Okay, let's try 1 by 10. Okay, so why didn't 1 by 1 work? 1 by 2? BFG doesn't like. All right, okay, that's fine, whatever. Okay, now let's put that into our thingy here. Let's change this to 3, and we're actually going to have to swap that out for a integer here, so that we can say that we want the third input to go to the matrix. Let's check to see if that's worked. Yes, it has. Right. Okay. Although it's slightly different. That's because that's got a 4th plane in it. Oh, I'm not going to worry about that now. Okay. So now let's see if that has indeed worked. Okay. I think that's working. So what I'm going to do is I'm going to make a pack offset 0, 0, 0. And then I'm going to make a float here and then see if I can change the... There we go, that's working. So I'm actually changing the, rather than the X and Y values, it's the W, or I don't know. So you can see how that's sort of changing like that. That's going to be reflected in our audio. Lovely. And because that's now a jitter matrix, we can use that to create some displacement on our grid shapes. So let's get our grid shape here. And let's say at matrix output 1. And then let's make a jit.gl.mesh at draw mode lines, I think. Connect that to that. Okay, let's try line underscore loop. Okay, you can see it there. So let's make a jit.op at op pass to pass the x-axis, pass to pass the y-axis, and plus for the z-axis, let's connect that to... interesting. So it's kind of done something. Maybe let's normalize this. Jit.normalize. Oh, okay. I don't know why it's gone pink. Anyway, let's have a look. Okay, let's make those lines a little bigger at line width 5. Yeah. Okay, let's change the draw mode to line strip. That's better. Yeah. Okay, so the function, the basis function, is kind of creating a wavetable, but also creating displacement in this geometry. We could sort of make it go even further by perhaps using a jit.catch at mode 3 and take the audio from the jit.peak. Let's just plug that in there like that. Let's just be messy about it. And use that. Let's see what that's doing. Okay, so that, let's try a different mode. Let's go with 3. Okay, so that is kind of like, so what we've done is we've taken a jitter. Oh, I'm not going to explain it. Let's just do it. Okay, so now what I can do is I can actually add that to this part here. So this is the matrix that's doing the displacement. Well, it's adding this data to the z-axis of this grid shape. So if I take that and add that to this, let's go jit.add and just connect that right in there like that. We get, woo, we get this stuff. But let's multiply, or maybe let's try jit.multiply. There we go. So now we've kind of got a little bit of visual representation of... Okay, let's maybe multiply this a little bit. Let's say jit.multiply at val 0.25 or something, just to sort of attenuate it a little bit. Let's have a look at this now. Okay, let's make a jit.time. Let's just plug that into that. Okay, I'm going to maybe, so I'll turn that down a little bit. I'm going to maybe multiply that a bit more. Jit.multiply at val 1, but then have a float in here so that I can maybe increase that. There we go. And of course, we can try different noise functions. Cell. Gradient. What about these fractal ones? Just makes a load of white. Turbulence is good. Get some good results with that. Transfer sine. Ha! Okay, very nice. I like noise.distorted. I find that I get the best results out of that. Right, so that is pretty much everything I wanted to cover. This is a starting point for you to create your own visual audio patches where the audio is actually created by the visual content and not the other way around. I'll probably do some audio visual stuff in the future, but this is something I'm kind of interested in right now, that actually the visual is the starting point rather than the audio. And then you get, because a lot of this mathematics is all the same: cosines, sines, squares, you know, zeros, ones, 0 to 1, all that sort of stuff. It's all kind of the same mathematics. So they are inevitably going to be related. Anyway. Yeah, if you put it down really low, it sounds sick. Stick some reverb on that. Get the gigaverb. Where's it? Go to beep. Get the gigaverb in. Where is it? Gigaverb. Yeah. Plug that in. Plug the gigaverb in. Yeah. This is well good. This thing. Oh my goodness me. There's no dry wet on it, but anyway, it doesn't matter. Cool. All right, I'm going to go and put this on my Patreon now, where you can do the Patreon thing and get access to this patch plus many other patches, Ableton stuff, Mac stuff. Thanks for watching, everyone. Have a nice time. Happy patching.